Curves in industrial design. Notes of a B-spline curve. The basis functions of a B-spline curve depend on the time needed to traverse each Bezier piece of the curve. On the left of the screen, we can see a B-spline curve composed of 3 cubic Bezier pieces. H equals 1 means that the time needed to traverse each of the Bezier pieces is 1. On the right-hand side, we see the basis functions that compose the B-spline curve. We mark in red the basis functions that correspond to the first control vertex. This function is positive in the interval 0, 1 and is 0 outside that interval. When we make h larger, what we are doing is that we are taking longer to traverse each of the Bezier pieces that compose the curve. The shape of the curve of the B-spline curve has not changed, but the basis functions have changed. For the basis functions that correspond to the first vertex, the first basis function, we see now that it is positive in a larger interval. In fact, it is positive between 0 and 1.5. That means that the basis functions depend on the time needed to traverse each of the Bezier pieces of the B-spline curve. The support of a basis function is defined as the largest interval where the function is positive. The support includes the endpoints of the interval. On the picture we see the support of an order 3 basis function, which is the interval 0, 3, where the function is positive. Outside that interval the function is 0. The notation for the support is sup of n2, 3. In this case, the interval 0, 3. The nodes of a B-spline curve are the endpoints of the supports of the basis functions that define the curve. The supports of the basis functions of a uniform cubic B-spline made of 3 Bezier pieces defined for t between 0 and 3 are shown below. The support of the first basis function is the interval 0, 1, where the function is positive. For the second basis function is 0, 2, 0, 3 for the third and fourth basis function, 1, 3 for the fifth basis function, and for the last basis function is 2, 3. Here we can see all the basis functions together. The node vector comprises the nodes of the basis functions that define the B-spline curve, listed from smallest to largest. For example, the node vector that generates the basis functions of a uniform cubic B-spline defined by t between 0 and 3 and composed of 3 Bezier pieces is 0, 0, 0, 0, 1, 2, 3, 3, 3, 3. The first Bezier piece is defined in the interval 0, 1. The second Bezier piece is defined in the interval 1, 2. And the third Bezier piece is defined in the interval 2, 3. The endpoints of the support of the basis functions of order 3 are 2 nodes in the node vector that are 3 nodes apart. For example, the support of the first basis function is the interval 0, 1, which is the first node, and 3 nodes apart we find the 1. The support for the second basis functions is the interval 0, 2, for the third one 0, 3, and we find the rest of the supports the same way. If the node vector that generates the basis function of a cubic B-spline curve is 0, 0, 0, 1, 2, 3, 3, 3, 3, then the B-spline curve starts at the first vertex and ends at the last vertex of its control polygon. This is because the first node is repeated 4 times and the last node is also repeated 4 times. The number of repetitions depends on the degree of the curve. For degree 3, we need 4 repetitions. For degree 4, we would need 5 repetitions. The curve is uniform since, except for the repeated nodes, every 2 consecutive nodes are equidistant. In this case, the distance between 2 consecutive nodes is always 1. In this case, between 1 and 2 and 2 and 3. The curve is defined for t between 0 and 3 since the fourth node is 0 and the fourth to last node is 3. In many CAD tools, to draw a B-spline curve, the designer only needs to choose the vertices of the control polygon, but not the node vector. When this is the case, the spline is usually a cubic uniform B-spline. Only the control polygon D0, D1, Dm is needed to construct a uniform cubic B-spline. Since it is cubic with m plus 1 vertices, the number of its Bezier pieces is n minus 2. Since it is cubic and uniform and starts at D0 and ends at Dm, its knot vector can be chosen with h equals 1. We saw that the shape of the curve doesn't depend on the choice of h, and the first knot we can choose to be 0. If this is the case, the knot vector will be of the form 0, 0, 0, 0, 1, 2, up to m2 repeated 4 times. The B-spline basis functions can be calculated from the knot vector. The curve parameterization is then a linear combination of the vertices with the basis functions just constructed, and the curve is defined in the interval 0 and minus 2, which correspond to the fourth knot and the fourth to last knots of the knot vector.